Solid. I'm hollow. There's nothing behind my eyes. I'm a negative of a person. And as if I never thought anything. All I want is blackness and silence.
Introduction to data types. Data is a basic unit in programming. Without data, we couldn't write any programs. But what is data? We may be familiar with data as information, or facts. In computing, data is the pieces of information that we use to build programs, like the numbers in a calculation, or the text printed to a screen. Data types are exactly what they sound like. Different types of data. Data types tell us about the data, including how it can be stored and what types of operations we can perform. For example, we can write a program that squares numbers, but it wouldn't be able to square a word. In programming, there's a special group of data types called primitives. Primitives are the most basic data types, so basic that you can find them in pretty much every programming language. They include numbers, strings, Boolean values, true or false. In the following exercises, we will dig a little deeper into each primitive data type and what you generally can and can't do with each one. Instructions. Computers can do different things with different kinds of data. This computer will process data according to the function that you give it. If the function matches the data type, you will get an answer. If it doesn't, you'll see an error. The functions do the following. Capitalize will turn lowercase characters into uppercase characters. Square will square a number. Evaluate will determine if an input is true or false. Numbers. Numbers are the original data type. The earliest computers communicated only in numbers, using binary computation. We no longer just program using numbers, but numbers still have special properties and are used to do the following. Describe. Numbers are used to express value. What is the frequency of a sound wave? We can express that in a number, such as 800 Hz. Calculate. Numbers are used in calculations. What's the distance between the Earth and Mars? Count. Numbers are used to keep track. How many times did the car go around the track? While we can do a lot of things with numbers, there are a few things we can't do with them. For example, say we have the number 20 and the text, I am 20 years old. While both deal with the idea of 20 as a value, a computer could perform mathematical operations on the first piece of data, but not on the second. Instructions. Numbers allows us to write programs that store values, count, and make calculations. This program calculates the numerical distance between different points in space and keeps count of how far we've gone. Strings. But what if we want to work with data that isn't a number? we can represent other forms of data as a string. Strings are any sequence of characters, letters, spaces, numbers, or symbols. While almost anything can be a string, they are typically used to represent text or speech. Similar to how we represent speech in writing, we surround strings with single or double quotes. But why the name strings? Strings are a sequence of symbols, so we can think of each character as being strung together, like beads in a necklace. So, what can we use strings for? To display data that uses text or symbols, like printing our name to the screen. To add or remove text. Since strings are a linear sequence of characters, we can break strings into even smaller strings, or combine strings to make longer ones. To modify characters. For example, we could capitalize the first letter of every word in a string if wanted to turn it into a title. To let the computer communicate with us in a human-readable way, like displaying the rules of an online game. Strings may sometimes look similar to other data types, but it's important to remember that even if a number looks like a number, or a boolean looks like a boolean, it's good to check that it's not a string, or else you won't be able to use it correctly. Take the following string, 20. The string 20 is different from the numerical value of 20. While they appear to be the same, a computer would see the first as two characters, 2 and 0, while the second contains the numerical value of 20. Instructions. While we can think of strings as chunks of text, it's also useful to remember that they're just a collection of individual characters, like letters in a banner. Type a word into the box and see the result. Notice how each character is separate from the ones around it, but they come together to make a word. Boolean. This next data type has a special importance to computing. Boolean values represent the logical ideas of true and false. Booleans, unlike numbers or strings, only have two values, true and false. The term Boolean comes from the inventor of a specific form of logic, George Boole. Logic is important to computer science because it is an early attempt at translating the human capacity for reason to computers. So, what do we use Booleans for? To determine validity. For example, we want to know whether a meme is viral. If it's been viewed more than 50 million times in less than a week, we'd say that it's true that it went viral. To make decisions. For example, if I get an email, the program checks that the email is new and it displays at the top of my inbox. Because Booleans act as binary opposites, we can think of them in a myriad of ways, like on and off, yes and no, sometimes even 1 and 0. While we use the words true and false to represent Boolean values, it's important to remember that they are different from the strings true and false. Instructions. Programmers first were able to illustrate the idea of binary logic through turning on and off electric circuits, where on equaled true and off equaled false. In fact, the relationship between electricity and logic is the basis for digitization. Flip the switch to see the scene change from day to night and watch the lights turn on and off. Notice how the variable lights on stays the same, but its value changes from true to false. putting it all together. So far you've learned about 3 different data types: numbers, strings, booleans. Let's put your knowledge to work. In the code editor, we've listed 3 variables, each equal to a different data type. Try choosing a function and see what it outputs. Instructions. Now, let's change the values of the variables. Press the Run button, then select a function from the drop-down menu and see how it evaluates each value. What happens if you change the value, but keep the data type? What happens if you swap out the data type? Anytime that you change the code, make sure to run your code again. Otherwise, the computer won't know that you made a change. Data types review. Congrats! Now you know the building blocks of most programming languages and should start to have an idea about the types of simple programs that you could write. In this lesson, we learned categorizing information using data types is a way for a computer to distinguish different types of input. Primitives are the simplest data types and are shared across many programming languages. They include numbers, values that allow us to do calculations and keep count. Strings, a sequence of characters or symbols often used to denote text. Booleans, logical values that represent the idea of true or false. Strings are called strings because strings form the parameters of our program, like string wrapped around a package. Strings are a sequence of symbols, so we can think of each character as being strung together, like beads in a necklace. Strings represent different musical intervals, like the strings on a violin. Strings connect two pieces of code, like sheets of cloth sewn together with string. Data types are important because they are a recent development in programming. They identify different information used in programs. They increase the number of lines in a program. True or false? Is this value a string? My favorite show equals 24. What data type is used in this code block? Is touching equals true? String, number, Boolean. Primitive data types include numbers, booleans, variables, arrays, lists, strings, numbers, booleans, strings, dictionaries, integers. Correct. These three are all considered to be primitive data types. Quiz scorecard 00%. Great job. Operators. Introduction. In computing, we work with lots of different forms of data, but the real fun comes when we can do something with this data. In this lesson, we'll look at how we can write short computer programs using operators. Operators are different symbols that represent an operation, such as the plus sign, plus, as a symbol for addition. Operations enable us to process our data, to transform it into something else. You may already be familiar with operators and operations from other contexts. This lesson looks at different ways we can use operators in programming, including making calculations using arithmetic operators, comparing information using comparison operators, creating logical expressions using logical, aka Boolean, operators. Instructions. We can think of writing a program as similar to following a recipe. In this lesson, we will look at how we can use operators to make a fruit salad. To make the salad, we will use operators to calculate the fruit needed, compare the different fruits, determine if we have the right ingredients. Right now, we can only add or take away data points by manually including them or deleting them from our code, sort of like adding and subtracting. When you're ready, move to the next exercise. Using operators to make calculations. Think about the last time you needed to perform long division. Did you write it out on paper or reach for a calculator? We can actually write computer programs that perform calculations for us. In fact, that was their original purpose. If we want to write a program that performs calculations, we need to use arithmetic operators. They include addition, plus, subtraction, multiplication, asterisk, and division. Addition adds an amount to a number, 2 plus 3 equals 5. Subtraction takes away an amount from a number, 10, 3 equals 7. Multiplication takes a number and repeats it a specified number of times. 5 * 2 = 10. Division takes a number and divides it by another number. 15. 3 = 5. How does this work in real life? Let's say we need to buy some apples for the fruit salad recipe. The recipe calls for 6 apples, but we can only find bags of 5. If we buy just enough bags for your recipe, how many extra apples will you have? Since one bag isn't enough, we need to buy 2 bags with 5 apples each, which would equal 10. Then, we subtract the 6 apples that we need for our recipe to find our answer. If we were to print out answer, it would equal 4. You may notice that unlike in math class, we put the answer on the left-hand side of the equals sign, rather than to the right. That's because we're saving the value of our answer to a new variable. So, apples, my apples, and answer are all variables. Instructions. Let's calculate how many apples we need for our fruit salad. The recipe says that for a fruit salad that serves 4 people you will need 4 apples. But you're making a fruit salad for a party, so you need to double the recipe. Use the buttons to calculate the correct amount of apples to use in the fruit salad. Note: you start with 0 apples, and will need to use add to get your first apples. Using operators to make comparisons. When writing a program, we often need to check if a value is correct or compare 2 values. Comparison operators allow us to compare values and evaluate their relationship. Rather than evaluating to an integer, they evaluate to true or false, aka Boolean values. Expressions that evaluate to Boolean values are known as Boolean expressions. Comparison operators include less than, value to the left is less than the value to the right, 2 less than 6. Greater than, value to the left is more than the value to the right, 14 greater than 5. Equals, value to the left is equal to the value to the right, 3 = 3. Note: we use a double equal sign to show that we're checking the value, rather than setting it equal to something, like we would with a variable. Some languages even use a triple equal sign to super triple check. There are 2 main instances where we use comparison operators. If we have an unknown quantity, what if we knew that we needed a ½ pound of strawberries, but we didn't know the weight of each strawberry? We could weigh the strawberries and see if the total weight equals a ½ pound. If we need to compare 2 known values, if we're making a salad that's super citrusy, then we need to make sure we have more oranges than bananas. If that's false, I'll have to add more oranges. Instructions. For once, let's compare apples and oranges. Our fruit salad recipe gives us a couple options for apple to orange ratios. If we want a balanced salad, we should have 3 apples and 3 oranges. If we want a more citrusy salad, we should have 5 oranges and 3 apples. If we want a less citrusy salad, we should have 4 apples and 2 oranges. From left to right, follow the provided recipes and select the correct comparison operator for each one. Why is it helpful to be able to check or compare different values? Using operators to get different outcomes. As we saw, comparison operators allow us to examine the relationship of 2 values. But what if we're looking at more than 2 values? Logical operators, also known as Boolean operators, evaluate multiple Boolean expressions. Rather than determining if one relationship is true or false, it looks at several relationships by connecting them with logical operators and then determining the logic validity of the overall expression. Logical operators include and. Both expressions evaluate to true, so the final result is true. 4 greater than 1 and 2 less than 7 is the same as true and true. Evaluates to true. Or, one of the expressions evolutes to true, so the final result is true. 8 greater than 6 or 3 greater than 6 is the same as true or false. Evaluates to true. Not an expression, no matter its logical value, evaluates to the opposite. Not 1 less than 3 evaluates to not true. Evaluates to false. The examples given are only a few of the outcomes that you can reach using logical operators. Using logical operators and Boolean expressions enable us to handle different scenarios in our program. For example, what if we only had apples in our fridge? If a recipe asked for either apples or pears, we could still make the recipe. But if a recipe requires both apples and pears, we wouldn't be able to make it. Instructions. Take a look at these following recipes and determine if you can make them with the fruit on hand. You have a fruit salad recipe that calls for 7 apples and 4 oranges. You have a juice recipe that asks for 8 apples, but you could also just use 8 oranges. You have a recipe that is for applesauce. How do Boolean operators allow us to make our programs more flexible or more strict? Can we start to see ways we can write programs that can handle different scenarios? Putting it all together. Now that we know a bit about different operators, let's try writing our own expressions. As we've seen, We can use operators to change something's value, add other things to our program, to take them away, or to perform calculations. We can also use operators to compare statements or determine whether they are true or false. One important thing about operators when you program is that they may look different from language to language. That's because different programming languages have different syntax or rules for how they are written. Instructions. Let's use the operators that we've learned to add different fruits to the screen and determine their relationships. Create a variable named orange and set it equal to 4. Decrease the number of oranges from 4 to 2. Save the result to the orange variable again. Run the code and see how many oranges appear on the screen. Review. Congrats! Now you know about different operators and how they can be used to build simple programs. In this lesson, we learned operators are symbols that represent different ways of modifying, comparing, and evaluating information. Arithmetic operators are used to make calculations. Comparison operators determine the relationship between two values, which results in a Boolean. Logical operators determine the logical state of multiple Boolean values or expressions, which results in another Boolean. Now that you know the building blocks of operators, how can you further combine them to write programs? What is an operator? A numerical data type. A statement that evaluates to true. A symbol that performs calculations, like addition. A programming language. Correct. Operators represent an operation that we can perform on a piece of information. Logical operators and comparison operators evaluate to which data type, Boolean, string, number. Correct. Both of these types of operators will result in Boolean values, true or false. You have 5 forks and 3 spoons. Fill in the blank to create the correct comparison expression. You got it. Arithmetic operators are used to determine if something is true, make mathematical calculations, store a value, compare different amounts. Correct. Arithmetic operators can perform mathematical calculations, like addition and subtraction. You have 8 plants. Plants equals 8. Does this statement evaluate to true or false? Plants equals 4. Correct. Plants does not equal 4. The correct statement would be plants equals 8. 100%.